Hello and welcome to Grokking Graph Analytics and Algorithms. Let's go ahead and summarize what we've covered in this section of the course. Depth-first search is an easy-to-implement algorithm that's memory-friendly and can find solutions to simple mazes. It does, however, perform poorly on some more generic search tasks. Breadth-first search is a bit more memory-intensive, but can find target nodes in the minimum number of hops. You can implement it with a queue to keep track of the nodes in a first-in, first-out priority. Another way to think about breadth-first search is that you're using an expanding search frontier and go further and further away from the starting point. We also covered Dijkstra's algorithm, which helps us find the lowest cost path in a weighted graph. This could be used in problems such as route planning with a map. This is an improvement over our previous search methods, which only considered the number of hops from node to node and not the cost of each hop. Dijkstra's algorithm uses a min heap to track our nodes and leverages relaxation to continually improve the cost to travel to each node. Dijkstra's algorithm fails for graphs with negative weights, so consider using Bellman-Ford instead. Lastly, we covered Eulerian paths. We found a way to determine whether a graph had an Eulerian path by counting the degree of each node. We reviewed Hierholzer's algorithm, which helps us find Eulerian paths and circuits when they do exist. In addition to reviewing some algorithms, we spent some time practicing converting real-world systems into graph data structures. Remember, the question to ask is, what are our entities? And what are the relationships that matter between those entities? This translates into nodes and edges. Identifying nodes and edges is a vital skill in graph analytics. Take time to practice making these relationships with systems in your day-to-day life. This could include atoms and bonds between them, molecules and the energy that release or absorb during a reaction, your family and friends and how they feel about each other, or just the cars and the traffic that you're stuck in. So that's it for the paths section. I'm going to add a few example problems to this section, but if you understand the algorithms, there's no need to go over those. I do encourage you to apply the algorithms by hand on a few small graphs. This has been shown to improve retention over time. I'm going to provide some Python code to implement these concepts, but I challenge you to develop your own. Think about test cases and what kind of things might be different in your implementations, or even in the answer that your code gives. The next section will cover connections. This is an exciting topic that helps us to do things like identify popular people in a social network, weak spots in communication networks, and even improve the importance of search results. I'll see you there for a lot more on graph analytics.